Okay, so this is the first. This is, I think it's chapter 4, 5, or 6. It's called Systems of Linear Equations. So this is important. It's going to show up in vectors, and so we have to do it now. And anyway, so this is going to be a lot of writing. Ready? Okay. Systems of linear equations. Now, in the last class, we talked about the intersection of lines and conics, but today we're talking about just we're finding the system, the solutions to two or three equations. Okay, so how did we do it? Well, the first thing we did, let's start with an example. Y equals 2x plus 1, and y equals 3x minus 3. And what you originally did was we solved it graphically. So we solved it graphically, right? So you put it on your graph paper, and you made the sketch. So let's... Oh, the lights went out, sorry. I'm waiting, I'll cut this out of the video. Come on. Nice. Okay, so let's call this first line. So we know that this is like 2x plus 1, and this is the second line. We know that this is, 3x plus 3. So we know that this is the solution. This xy is the solution here. And so we could do this graphically, but then we realized that the numbers started to get a little weird, and we needed algebraic approaches. But once again, we always start in geometry and move to algebra, right? So this is the geometric solution. Actually, it's interesting because we're going to be looking at planes in 3 space, and so this is going to have a geometric implication for us. But what was the algebraic solution? We said, you know what, they're both equal to y, so we set them equal to the 2x plus 1 equals 3x minus 3. We have x equals 4, and then we found the solution, and then we substituted back into both equations. So y equals 2 times 4 plus 1 equals 9. Maybe the good student wanted to see it also work. We plugged it in. Y equals 3 times 4 minus 3, which is also 9. So the solution is either the points 4, 9, or you could write x equals 4, y equals 9. Now, this idea of substitution we saw substitution was helpful. So, for example, we saw y equals x plus 2, and we also were given the equation 3x minus 4y equals 20. And so our technique for substitution was we hoped that one of the variables was solved for like x or y. In this case, y equals 2x, and then we did substitution. We stuck it in there, and then we had 3x minus 4 times 2y equals 20. Negative 5x equals 20. We had x equals negative 4, and then we plugged it back into both equations. We plugged it back to both equations. And so we saw that, y equals 8, and then also it was negative 12 minus 4 times y equals 20. So we got negative 4, that was negative 4, y equals negative 8. The good student checks it in both equations. So we plugged our negative 4 back into our original equation. We got negative 12 minus 4y equals 20. Negative 4y equals 36, y equals 32, y equals negative 8. Well, that was day one, we kind of moved on to the process of elimination. And so the idea is you were given this equation, x plus 5y equals 11, and you were also given the equation 3x plus minus 2y equals negative 1. Now, you know these are lines, and you can plug it in Desmos, or you can use your GDC to find the solution. I want you to know how to do that. But we're going to be doing it analytically, that is by hand. So the technique was elimination. If I can manipulate one of the equations so that the coefficients are the same, I can add or subtract the equations together and have and eliminate one of the variables. And so in most of these problems, one of the variables is going to have a coefficient of 1, and that's the coefficient you're going to manipulate. So we're going to say, you know what? I'm going to multiply. If I call these rows, right, I'm going to multiply the first row by 3 to give me my new first row. And so I have 3x plus 15y equals 33. And then I have 3x minus 2y equals negative 1. And then what's the next manipulation you're going to do? Well, we're going to subtract this. So 3x minus 3x is 0, 15 minus 2 is 17y, and 33 minus negative 1 is 34, and then y equals 2. And then what was the next thing? Check in the original. Right? And so, let's see, x plus 10 equals 11, so x equals 1, and then 3x minus 4 equals negative 1, 3x equals 3, x equals 1. Nice. So that was the idea of elimination. So x equals 1 and y equals 2. But this was the idea of elimination, that I can multiply an entire row by a number. And that the other issue with the elimination is that I can add or subtract rows together and come up with a new statement. Page 2. Next example. Yeah, so you can see all the way to here. Perfect. So next example was 5x plus 2y equals 13, and 4x minus 3y equals negative 8. Now, the coefficients are none of them are 0, and I can't solve for y. Once again, I could use Desmos, I could use my graphing calculator, but once again, what's the technique to eliminate? Well, you were told, I kind of tell the students, find the coefficient with the opposite signs, and then multiply the other row by that. And if you notice, I'm allowed to manipulate my row and maintain the relationship. So if I multiply everything by 3, it's still equal to each other. And if I multiply the second row by 2, it's still equal. Well, I rewrite it over. 15x plus 6y equals 39, and then 8x minus 6y equals negative 16. Am I going to add or subtract these equations together? We're going to add them because the 6 and negative 6 are opposites. So 15 plus 8 is 23x. 39 minus 16, well, lucky me. X equals 1, and then you plug it back in. But we're going to use a more, now, you know how to do this, and you can do this with 2 equations, you can do it with 3 equations, but I'm going to show you a more elegant method. It's called Gaussian elimination. The idea of Gaussian elimination is we're going to take we're going to write all the coefficients, right, along with what they're equal to, and we're going to convert it to looking at the identity matrix. We're going to get rid of ABC. We're going to turn it into 1, 0, 0, 1. And so let's see what happens. let's take our original. Now, in this class, one of the equations is always going to have a 1 in front of the variable because this isn't algebra 2, it's HL. And so we have other things we want to do with it. So we're not going to get too much caught in the muck. Okay, so let's go back to original. I'm going to rewrite this, ready? First of all, step 1, write it in matrix form. We're going to rewrite this as 1, 5, 11, 3, -2, -1. As I said before, I want to get rid of this 3, and I want to get rid of this 5. The first thing I'm going to do is a little manipulation. I'm going to say, ready? Row 2 minus 3 times row 1 is my new row 2. Okay, well, did I have any instructions for the first row? No, leave it. And I'm sorry, this is row 1, this is row 2, and there's going to be a row 3. Okay. Well, what do I do to row 2? 3 minus 3 is 0. -2 minus 15 is -17. -1 minus 33 is -34. Nice. Next thing, I'm going to clean up row 2. I'm going to clean up row 2 a little bit, and I'm going to say row 2 divided by -17 is my new row 2. Nice. Okay. Let's see. Can I see this? Can you see this? Yes. Okay, so what's my new? Did I change row 1? No. 1, 5, 11. Did I change row 2? Yeah. 0, 1, 2. Nice. Now I'm going to get rid of that 5. So, row 1 minus 5 times row 2 is minus is my new row 1. Okay, so 1 minus 5 times 0, 1. 5 minus 5, 0. 11 minus 10, 1. Was there any change to row 2? No. X equals 1, y equals 2. Let's try another one. Page 3. Let's see. Next, x. 5x minus 2y equals 2, and x plus 3y equals 14. Okay, so your first thing is to say, don't write this down. Your instinct is, okay, 5, -2, 2, 1, 3, 14. I'm going to tell you, put the equation that has the x with the 1 as the first equation. So we're going to write 1, 3, 14, 5, -2, 2. Because we want to get the 1, 0, 0, 1. Okay, so, sorry, let me close my caps. I want you to think about this for a second. Okay, so I need to take care of row 2. So row 2 minus 5 times row 1 is my new row 2. Were there any instructions for row 1? No, leave it. 1, 3, 14. Were there instructions for row 2? Yes. 5 minus 5, 0. -2 minus 15, -17. And then what's going on over here? 2 minus 70, 2 minus 70, negative 68. Okay. Last thing I'm going to do, well, not ready. Let me clean up row 2. Row 2 divided by negative 17 is my new row 2. And so I have, you can see over here? Can you see that? Yeah. I have 1, 3, 14, 0, 1, 4. Nice. Let's continue. We're almost done. We're almost done. What's my next instruction? Actually, I can write it down here. What's my next instruction? Row 1 minus 3 times row 2 is my new row 1. Nice. Well, so I like to write row, since I didn't have any instruction for row 2, I'm going to write that over. And you know what? I already know this is going to be a 0. That was my manipulation. 3 minus 3 is 0. What's going on over here for 14? 14 minus 12 is 2. X equals 2, y equals 4. Nice. Okay, a couple of issues. So I want you to practice this. We'll do some more. Yeah, let's keep going. Number 3. Next system. 3x plus 5y equals 12, and 6x plus 10y equals 24. Now you're looking at this and you're like, hey, Mr. Adler, those are the same equations. Do you need me? Oh, these are the same equations. So it's the same line. So you're like, well, there's an infinite number of solutions. Okay, let's see how this works out. Let's see how we know geometrically there's infinite number of solutions. Let's see what the algebra reveals. So we have 3, 5, 12, 6, 10, 24. Okay, so let's let row 2 minus 2 times row 1 be my new row 2. So we didn't do anything to the first row. We have 3, 5, 12. In the second row, we have 0, 0, 0. This means, when you have 0, 0, 0, this means you have infinite solutions. Infinite solutions. Because think about it. 0 times something plus 0 times something equals 0. It doesn't matter what you put in here. It's always going to be true. And so we know that, once again, geometrically, it's the same line. Can someone think of a system of equations that have absolutely no solutions? Well, geometrically, what lines never meet? What lines never meet? So you're like, okay, well, how about 2x plus 5y equals 10, and 2y plus 5y equals 11. You can say, well, they have the same slope, they're parallel lines, they're never going to meet. We know that from the pictures. How do we see that in this matrix? Okay, let's put it in the matrix. 2, 5, 10, 2, 5, 11. Let's say row 2 minus row 1 is my new row 2. We have 2, 5, 10, 0, 0, 1. What's going on in that second row? Should I even go any further? You say, no, Mr. Adler, because 0 times something times 0 times something. Remember, these came from our original equations. 0 times something times 0 times something can never, ever be equal to 1. No solution. And we say this is because it's contradiction. Page 4. Ready? Page 4. Okay, now let's do some 3 by 3s. Once again, with your 3 by 3 equation, these are going to represent planes in space, like the ceiling, the table, and we're going to be talking about this in the vectors unit, but we need to do the algebra now. Okay, ready. X plus y plus 2z equals 3. 2x plus y plus 3z equals 7. And negative x minus 2y plus z equals 10. If you're interested, go to, I think it's a GeoGebra 3D, and you can put these equations in. These are the equations of planes. And these are going to be 3 planes that meet at a point. Kind of like the way, right here. Like, see how these the 2 walls, right here, where that corner where the 3 walls meet, that's what we're going to be studying. So, but we need to do the algebra of it. Are we in there? Can you see everything? Okay. Ready? 1, 1, 2, 3. 2, 1, 3, 7, negative 1, negative 2, 1, 10. Well, I'm going to write 2 instructions because I have a 1 up here, so I'm going to take out all the x's. Eliminate the x's. Okay, my first instruction is row 2 minus 2 times row 1 is my new row 2, and row 3 minus row 1 is my new row 3. Nice. Let's see what's going on. I had no instructions for my first row, so I'm going to keep it the same. 1, 1, 2, 3. I had instructions for my second row. 2 minus 2 is 0. 1 minus 2 is negative 1. 3 minus 4 is negative 1. 7 minus 6 is 1. What's going on with my third row? Not subtract, add it together, right? Negative 1 plus 1 is 0. Negative 2 plus 1 is negative 1. 1 plus 2 is 3. 10 plus 3 is 13. Nice. Now, you can clean up the second row, or you can leave it. Let's leave it, because it's not a big deal. But once again, as you get it closer, you can say, oh, you know what, Mr. Adler? I'm just going to multiply all this by negative 1. I'm keeping it simple on the first day. So, let's eliminate the y. Eliminate the y. Okay, so you know what? Row 1 plus row 2 is my new row 1, because that's going to eliminate this 1 here. And row 3 minus row 2 is my new row 3, because that's going to get rid of my negative 1 in the third row. Are we still recording? Yeah, it's a long video, sorry. What's my new matrix? Well, let's see. Row 1 plus row 2. 1 plus 0, 1. 1 plus negative 1, 0. 2 plus negative 1, 1. 3 plus 1, 4. I didn't have any instructions for my second row, so it stays the same. 0, negative 1, negative 1, 1. What's my instructions for row 3? Okay. 0 minus 0, 0. Negative 1, something minus itself, 0. 3 minus negative 1, 4. 13 minus 1, 12. Okay. You know what? Now, let's do a lot of cleanup. Let's do some cleanup here. Let's take row 2 divided by negative 1. That's my new row 2. And row 3 divided by 4. That's my new row 3. Once again, you can pick up the pace. Okay. 1, 0, 1, 4. 0, 1, 1, negative 1. 0, 0, 1, 3. Now, let's eliminate the z. Eliminate the z. Okay, so I have a 1 here. Let's row 1 minus row 3 is my new row 1, and row 2 minus row 3 is going to be my new row 2. Well, let's see what's going on here. What's 1 minus 0? 1. 0 minus 0? 0. 1 minus 1? 0. 4 minus 3? 1. X equals 1. Now, what were my instructions for row 2? 0 minus 0? I'm sorry, this was a minus, right? 0 minus 0? 0. 1 minus 0? 1. 1 minus 1? 0. Negative 1 minus 3, negative 4, y equals negative 4. And then 0, 0, 1, 3, z equals 3. So I'm going to cut this video short because you've been watching. And so I'm going to put the last problem on the board for you. I'm going to put the last problem on the board, and that is on page 5. And I want you to think about how you're going to do this one. 2x plus 3y minus 2z equals negative 1. X plus 5y equals 9. And 4z minus 5x equals 4. I've thrown in a couple of tricks here. I want you to think about it. The answer is x equals 4, z equals 6, and y equals 1. I want you to verify this in the GDC, and then I want you to solve by hand. And then, please let me know if you want me to do some homework. If you want me to go over this, and you can do the homework. I uploaded a sheet, and then there's also going to be a whole other day on this. Yay.